Hi, I'm Andy and this is question 8 on the AQA Decision 1 paper from June 2010. For more questions on this exam paper, click the eye in the top right corner. In question 8 we're told that Nerisse runs a cake shop and she sells Christmas hampers where X is the number of luxury hampers and Y is the number of special hampers. Then we're given some constraints. We're told that it takes her 10 minutes to prepare a luxury hamper and 15 minutes to prepare a special hamper, and she's got 6 hours available each day. We're also told she needs to prepare at least 5 of each. She needs to prepare at most a total of 32, and she will prepare at least twice as many luxury hampers as special hampers. Then we're given information about our objective function. It says Nerisse makes a profit of £15 on luxury hampers and £20 on special hampers. And in part A, we need to show that X and Y must satisfy the inequality 2X plus 3Y is less than or equal to 72. Now, we've got 4 pieces of information that could give us constraints for this question. We've got this sentence up here about the time to make each one, and then we've got these 3 bullet points here. To get this inequality here, we need to use the first sentence up here before the bullet points. If you didn't spot that, it doesn't matter because you're going to have to find the other inequalities anyway later in the question. So the information that we're interested in is shown here. And we're told our decision variables X and Y are the number of luxury hampers and special hampers. And so if it takes 10 minutes to make a luxury hamper, then if we make X luxury hampers, we would do 10 multiplied by X for the total amount of time making luxury hampers. For special hampers, if each one takes 15 minutes and I make Y of them, then the total time to make those would be 15Y. And we're told that she has 6 hours available to make them. But rather than just putting less than or equal to 6, we need to make sure that we're using the same units for the whole question. So these were given in minutes, we need to convert this to minutes by multiplying by 60. So we get less than 360. And then if we divide through by 5, we get 2x plus 3y is less than or equal to 72 as required. In part B, we need to write down 2 more inequalities that model the constraints above, but we're not allowed to use X is greater than or equal to 5 or Y is greater than or equal to 5. So looking at our 3 bullet points here, we need to find 2 more inequalities. So using the first bullet point, she will prepare at most a total of 32 hampers. To get the total number of hampers, we simply need to add X to Y. And that must be less than or equal to 32. So that's our first inequality. The second constraint is a little bit more challenging and people often get this the wrong way round. So I'm going to simplify it by breaking up the problem. First of all, I'm going to get rid of this at least bit and I'm going to come back to that at the end. So I'm going to write a constraint for she will prepare twice as many luxury hampers as special hampers. So if we have X luxury hampers and Y special hampers, what I'm going to do is think about what would happen if I had a specific number of special hampers. So let's say I had 6 special hampers and I've got twice as many luxury hampers. That means I would have 12 luxury hampers. And then I think, what would I do to Y to get X? In this case, I need to multiply by 2. So I could say that X would be equal to 2 lots of Y. It's very easy to check. 2 times 6 is 12. Now that I've got that, I'm going to get rid of these numbers and I'm going to get rid of the equal sign as well because I need to deal with the at least part. So if I know I need at least twice as many luxury hampers, that means I need more of these than this. So the inequality has to be that way round. In part C, it says on the grid, draw a suitable diagram to enable this problem to be solved graphically, and we need to indicate a feasible region and a direction of an objective line. Before I start drawing everything on my graph, I'm first of all going to write down an objective function, and that needs this part of the question here. So it says I'm trying to maximize my profit, which is P. So I'm going to write P equals. And the profit I make is £15 on each luxury hamper. So that would be 15 multiplied by however many luxury hampers I sell. And then £20 on each special hamper will be £20 multiplied by the number of special hampers we sell. So the objective function is P equals 15x plus 20y. So here are all the constraints I found in the last 2 parts along with the objective function that I've just found. Don't forget there's the extra 2 constraints which say that x must be greater than or equal to 5 and y is greater than or equal to 5. And what I'm going to do now is draw these inequalities onto my graph. So starting with x is greater than or equal to 5, that's going to be a vertical line that goes through 5 on the x-axis. And if x is greater than 5, I'm interested in the region on the right hand side, which means I shade out the region on the left hand side. Next, I'll draw y is greater than or equal to 5. That is a horizontal line through y equals 5. And again, I want greater than, so I'm going to shade out the region underneath. Next up, I've got 2x plus 3y is less than or equal to 72. To draw this one, I'm going to use the cover-up method, and that means I look at what would happen when x is 0, in which case 3y is 72, and y would be 24. So 0, 24 must be on my line. Then I'm going to consider what happens when x is 0. In that case, 2x is 72, or x would equal 36. Be careful when you're plotting these 2 points, because the scale is actually 2 squares for each number. So I need to go 2 squares away from 35 rather than 1. And I need to go up through 24. I'm told I want the region below this line because 2x plus 3y is less than or equal to 72, so I shade the region above. Next up, I've got x plus y equals 32. When x is 0, y is 32. When y is 0, x is 32. And again, I'm told I want the region below this line, so there's only a small amount of the region that I need to shade out here. And my final constraint is x is greater than or equal to 2y. If it helps, you might want to think of this as a half x is greater than or equal to y, so I essentially need to draw the line y equals a half x. That's a line with a gradient of a half that goes through 0. Another point it would go through then would be 40, 20. And I'm interested in the region where y is less than a half x. That means I want the region underneath the line, and therefore I need to shade out above the line. So my feasible region is going to be in here. Finally, I just need to draw on my objective line. So I can draw this objective line for any value of p that I choose. There are an infinite number of parallel lines that would all represent the objective function. But it makes sense to choose a number of p that means I can actually use this objective line to find the maximum profit. So I want a line that comes perhaps roughly somewhere down here like this. When you're choosing a number for p, you want to choose a number that both of these two numbers go into. That means you'll end up with whole numbers on your axes to plot, which makes it a little bit easier. You also want to choose numbers that give you x and y that actually fit on your graph. So, for example, you may initially think, well, 15 and 20, 60 goes into both of those. Okay, and it might initially seem like a sensible choice. But then when you think about your coordinates, when x is 0, y would be 3. And when y is 0, x would be 4. And that is going to give you a really tiny line down here. But don't worry about it if you get it wrong first time. You use your guess to make a more sensible choice next time around. So quite clearly I need to go bigger, but not too much bigger. If I went 10 times bigger, these numbers would be 10 times bigger and I'd end up with 30 and 40, which is a little bit big up here. So maybe 5 times bigger and make this number 300 would be sensible. So we'll have 300 equals 15x plus 20y. This time, when x is 0, that's going to make y equal 15. So we could have 0, 15 on our graph. And when y is 0, x is going to be 20, so 20, 0. And those points would seem to work quite well. 0, 15 is here, 20, 0 is here. That should be okay. So I'm going to draw my objective line in blue so it stands out from the other lines, and it's going to go from 20, 0 to 0, 15. You might find it useful as well to turn the ends of these lines into arrows so that it makes it clear that it's your objective line and it stands out a bit more from the other lines you've drawn. Whatever you decide to do, make sure that you label it your objective line. In part D1, it says use your diagram to find the number of each type of hamper that Naresh should prepare each day to achieve maximum profit. So to use my objective line to find the maximum profit, I'm going to put my ruler along the objective line. So we take our ruler and we move it parallel to the objective line until we find the final point where it's going to leave the region. Now, it looks to me like it's going to be this one here, but it's really close there. If you're finding it's close in the exam and your objective line is quite a long way from the point, you might find it useful to draw a very faint line and then move your ruler and put it back on that line so that you can keep it parallel to the page, and then when you get really close to it, you can do the last bit of movement. So the max value is going to be here. Now if you've drawn your lines really precisely and you know exactly what that value is, great, just read the coordinates off the grid. If you can't see what the exact value is where these two lines intersect, all you need to do is solve simultaneous equations to find where they intersect. So this line here is x plus y equals 32, and this line here is 2x plus 3y equals 72. These will be fairly straightforward to solve. I'll take equation 1 and multiply it by 2. That will give me 2x plus 2y equals 64. Call that equation 3, and then I'll do equation 2 subtract equation 3. That will give me 2x take 2x is 0, 3y take 2y is y, 72 take 64 equals 8. Then all I've got to do is sub that back in, and if I sub it back in here, something plus 8 is 32, that means x will be 24. At this point, make sure you answer the question. It's asking you how many of each hamper Nerys should prepare every day. So don't leave your answer in terms of x and y. Write down that we need 8 special hampers and 24 luxury hampers. Finally, in D part 2, we need to calculate this profit. So for this, go back to your original objective function, which says that p equals 15x plus 20y, and substitute in your values. This gives us p equals 15 times 24 plus 20 times 8, giving us a profit of £520.